in finding the derivative of the integral of h of x, k of x of a function like m of t dt when you're taking the derivative, it is equal to, so you're going to take the upper bound, take the derivative of the upper bound, substitute that into the function m of kx minus, now you're going to take the derivative of the lower bound, h prime of x, and substitute that into the function, then simplify. So here our question says you have g of t, which is given to you as the integral 0 to t of sine of x squared dx. So the upper bound that you see is t. You're going to take the derivative of t, and then you're going to take the derivative of 0. Don't forget to do the substitution as well. G prime of t becomes the derivative of t sine of t squared minus the derivative of 0 times sine of 0 squared. The derivative of t is just 1 multiplied by sine of t squared minus, well, the derivative of 0 is basically 0, so this is sine of t squared. Another function that we have is f of x which is given to us as the integral. Now you have x to 4 of 2 plus square root of u to power 8 du. To find the derivative of f prime of x is equal to the same process. You take the upper bound, find the derivative, do the substitution, and then you take the lower bound, which is x, take the derivative of the lower bound, do the substitution, square root of x to power 8. Basically, this is just 0, so the first quantity becomes 0. The derivative of x is just 1, so f prime of x is equal to -1 times 2 plus square root of x to power 8, or the differential of f is minus 2 plus square root of 8 to power 8. Next question for you. Suppose you have h of x to be the integral of 2 to 1 over x of sine to the 4th of t dt. We want to know what is the derivative of this function. So let us take the derivative of the upper bound. So you have 1 over x derivative, do the substitution into the function, minus, take the derivative of lower bound, which is 0 basically, but we're going to write down everything for you. So this guy becomes 0, so you don't have to rewrite this again. H prime of x is equal to the derivative of 1 over x is -1 over x squared sine to the 4th of 1 over x. Next function. Suppose you have another function like h of x, which is the integral of the lower bound is 1, the upper bound square root of x of s squared divided by 1 plus squared ds. So we're using a new variable, absolutely fine. No one's stopping us. H prime of x is equal to, you take the upper bound, find its derivative, do the substitution. Well, for substitution, I need a little bit more space. Here you have square root of x to the second divided by 1 plus square root of x to the second. Then the derivative of 1, which is just 0, times 1 squared over 1 plus 1 squared. But again, since the derivative of constant is 0, this guy becomes 0, so we're not really worried about that. So h prime of x becomes the derivative of square root of x is 1 over 2 times square root of x. Square root of x to the second is x, and down here you get 1 plus x as well. So you can simplify h prime of x to be x divided by 2 times square root of x times 1 plus